Hello everyone, welcome to another class. In this class, we are going to discuss data analysis with the Pandas. So Pandas and NumPy, these are the two main libraries which we are going to discuss in this video. And there will be one more part which will be coming after this video. So in both videos, we are going to discuss about the data analysis part, that how we are going to do the data analysis with using Pandas library and NumPy library. These videos I have structured in such a way, I have organized the programs in such a way that how efficiently you can use the functions and the uh, related functionalities of these two libraries, as well as how you can use these two libraries in the terms of data analysis, which now these days this is the most of the trendy or the domain in which we are using the Pandas library. So our today's topic is data analysis with the Pandas. So before starting our today's session, I would like to explain first about the data structures. Data structure, in which I would like to explain about the arrays. In array, I would like to explain about the 1D array, two-dimensional array, as well as the n-dimensional array. As well as we are going to discuss about the series and the data frame which we are using in the Pandas. Most of the videos I have seen which are surfing over the internet, a lot of content articles I have seen, they just randomly start teaching or explaining with the Pandas and NumPys, that how we can use these two libraries for the data analysis. But it will be more confusing. So to understand the Pandas and NumPy library for the analysis part, we must understand how the data is stored in these and how we are going to use these libraries. So first of all, I would like to explain about the arrays, then one-dimensional array, two-dimensional array, and then n-dimensional array. Then we will be discussing about the series and data frame. After that, we are going to start our today's session. We will be discussing few programs, how are the different operations we can perform on the series, on the data frames. Mainly using, we are using the data frame for the analysis part in the Pandas. So let's start. First of all, we are going to discuss about the array. So students, array is a collection of same data types elements which are stored together, which are stored together. So this is the definition of array. In Python, we are using mostly with NumPy library. So before starting anything, let me explain what is the use of NumPy library and Pandas library, because these are the two one of the main libraries which we are going to discuss in our today's class. So yes, NumPy, which means numerical Python, and Pandas, which means the library which we are using for the data analysis, and NumPy we are using for the numerical calculations. So so in the numerical calculation, NumPy is more efficient. As well as for the data analysis part, further we will be using the matplotlib, in which we are going to discuss how we can plot the data in visual formats, in charts, in graphs, in different charts. So that also we will be discussing in upcoming videos. So now let's discuss the 1D array, or we can say one dimensional array. So one dimensional array is a simply single list of elements. It has only one dimensional, or we can say only one row of data. Let's understand by the example. So before using any library in the Python, first of all we are going to import that library in the environment. So for using that, I would like to import NumPy as NP. You can import the library with your name also. If we are not going to use this as NP, then also it will not cause any error. You can directly use NumPy. Just for creating the short form of its, we are writing this NP and this as a alias, that we are using this NumPy as a short version of this. You can just write your name also. So NP dot, let's declare the variable first. Let's declare array 1 dimensional, then np dot array, and let's pass the list inside it: 10, 20, 30, 40, and 50. Now let's print this print a1. So this is the one dimensional array which we were discussing about. So this is how you can store the same data type in one single row in one dimensional array. So now let's discuss about the two-dimensional array. So a two-dimensional array has row, rows and columns. We can say like a matrix. I hope everyone has studied about the matrix. So in matrix we are having rows as well as the columns. So as well as we can say in two-dimensional array, it is we can say multiples of one-dimensional array also, because in one-dimensional array, as we have discussed, there will be only one row which we are discussing about. In two-dimensional array we are going to discuss about the multiple rows and columns. So it is a two-dimensional and 1D was one-dimensional. Now let's discuss with the example first. We have already imported the NumPy library, so no need to import it again and again. We will just directly use the NumPy array. Let's declare the variable a2, then np dot array. Let's pass two list here: 1, 2, 3. Pass the another one: 4, 5, 6. And now let's call it for print a2. Okay, one more time we have to create the list here, because then only it will be treated as these both elements. Yes. So now as you can see here, 1, 2, 3, 4, 5, 6. Now here we are having two rows and here we were having the single one. So as we can say that 2D array, two-dimensional array, having the rows as well as the column. So 1, 4 is one column, 2, 5 is the another column, 3, 6 is another column. 1, 2, 3 is one row, 4, 5, 6 is another row. So when the data will be stored like this, we can say the data is stored in two-dimensional array. When the data is stored in one single line of elements, or we can say one single row of data, then we can say the data is stored in one-dimensional array. So now if we are going to discuss about n-dimensional array. So basically in n-dimensional array, we are storing like the images and the multimedias type of data which we are using. ND array means an array with more than one dimensions. For example, we can say which we are using in the machine learning. We are using for the deep learning. and as well as we are using for the image processing. Now here ND array, which means it can be 3D array, 4D array, it can be 5D array. So these are the part of the n dimensional array. So now we are going to discuss about the pandas. So the array was the part of the NumPy library. We are going to use it with the NumPy. Now we are going to discuss about the pandas library data structure, that is series as well as the data frame. Series is kind of similar to the one dimensional array, because in series we are storing the data in we can say one column, or we can say, now let's discuss first, then I will explain with the example. So now we are going to discuss about series. So series, which we are using it with the pandas library. Series is a one dimensional labeled array. Now why I have used here this labeled word, because as I just now I have explained you that in array also we are using, that is a single list, or we can say a single row of data. In the series also we are going to store the data in one single column or the row, we can say, but it is a labeled array, which means there will be a labels, there will be a serial number, the way we are storing the data in tables. So we can say one specific column, we can say a series, multiple columns, or we can say a data frame. So we will be discussing by the example. So series is a one dimensional labeled array, we can say a array with labeled index. We can say a array with a labeled index. Now let's discuss with the example. So for using the series, we are going to import the pandas library. Let's import the pandas as PD. Now let's declare the variable p1, then pd dot series. Inside the series, let's pass a list here 10, 20, 30, and now let's print p1 here. Now as you can see, this is the difference between one dimensional labeled array and one dimensional array. So if we are going to declare the one dimensional array, so it will be a one row of a data, we can say. But here if you are going to use the series, so then there will be a proper labeled index. There will, now this is a column here, 10, 20, 30. 10 value is stored at zeros index, at first index. 20 value is stored at second index, at second place. 30 value is stored, and by default it return the data type also, that we are storing the data in a, this is a integer 64. In this one we are storing this data. So by default it will return the data type of your values which you have entered, as well as the labeled indexing also. So if we are going to discuss about the data analysis, we must have a labeled data set, then it will be very easy to do the analysis with the data. So now let's discuss about the data frame. So data frame is a two dimensional table with rows and columns, or we can say, for example, we can take a database table. We will be discussing with the help of one example. Pandas library we have already imported, so no need to import it again and again. So let's use this. Let's declare a variable that date. So in date, in data frame we are going mostly we are going to use the dictionary. So the dictionary will be converted into the data frame. So let's discuss how it will be converted. As we have discussed in the dictionary, that in dictionary we are storing the data in the forms of key and value pairs. So this name is a key here, and now let's store the data in as a value here. As a value we are storing the data as a list. Then let's store the data Mohan Jakhar. We have to enclose inside the strings Aman. So now one more list I want to pass, that is marks of these students. Marks they got 40, 100 and 50. So now we are having a dictionary here. And dictionary, the variable which we have stored, that is a data. Date. In date, what we are having, let's take change the name of this variable, data. So what data we are having? We are having as a data that is name. In name, we are having Mohan, Jakhar, and Aman as a name, as a value here. Then we have declared another key here, that is marks, and we are having the values for the marks. So as we have already discussed in dictionary part, that we are storing the data in key value pair. So this name is a key and these are the values. Marks as a key, these are the values. So now let's discuss how we can convert a dictionary into the data frame for the data analysis part. So for that, now let's take the another variable here, df, then pd dot data frame, and now let's convert this data into data frame. Now print this data frame variable, and now let's see. As you can, so the way we were having the data, now can you see, now this is more organized way. Now this data looks in a more structured way, in more organized way, and now it becomes more easy for us to understand that what are the columns here, what is the data with the labeled indexing also. So it will be very easy or convenient for the analyst to do the data analysis using the pandas, using the data frames. So now we are going to discuss the difference between the one-dimensional array and series, two-dimensional arrays, and the data frame. One thing is common between one-dimensional array and series, that in both we are storing the data in one dimensional in data frame, and in two-dimensional array. The main or the common part is that in both we are storing the data in the forms of rows and columns in two-dimensional. But the difference between the array and the series is, in series the data is stored in form of with labeled indexing. Same as well as in the data frame also, the data is stored in we can say in the terms of database table or the table, because there is a proper indexing. As well as there is a one another difference, in series we can store the data of different data types, but in array it is a collection of same data type in contiguous memory location. So I hope these few terms are very clear to you before starting the data analysis with the pandas. Because prerequisite we can say, or we can say the basics must be clear before starting or before approaching a big topic, or like if I will directly start explaining about the libraries and their functions, so it will be bit typical to understand that why I have used this data frame keyword, what do you mean by series, one dimensional array, two dimensional array. So I hope from now onwards in this video it will be very easy for all of you to understand what do you mean by data frame and series and arrays and NumPy? Because we must know how the data is stored, then only we will be able to analyze the data. So now the real part starts, that we are going to discuss about the data analysis, about the operations on the series as well as the data frame. So first of all, let's discuss about our today's flow of session. That introduction of the library part is covered. Now we are going to discuss operations on series. Then we are going to discuss operations on data frame. Then we are going to discuss row and column operations. And in the last, we are going to discuss about the importing and exporting CSV files. So in our today's class, we will be discussing about these topics first. Okay, so our first program, the very basic one, which I have already told you, but now let's discuss it again, that how to import library in Python. So whenever you are going to import any library in the Python, you will be in need this import keyword. This import keyword is very important, because by using this keyword we will be able to install any Python library inside our Python program. So first of all, we are going to import that NumPy as NP, as well as let's import again, import pandas as PD. So we can pass one message also, that both libraries are imported successfully. So now we are going to let's discuss about the second topic. This is also we have discussed, but let's discuss it again, that creating a series. So for creating a series, let's declare the variable first. Now let's take the declare variable v. Inside the v, I want to store the data in list 10, 20, 30. I want to convert this into a series. First of all, we will understand that if let's print this v first. So this is a list here. As you can check the data type also of this v here. So this data type of this is list. So now I want to convert this into, let's check another variable, that series 1. So now let's convert this into series pd dot series, and then pd dot series. Now pass this value as a v here, because in v only we have stored this list. So now let's print series, okay, series 1. So now as you can see, this is the difference. in the list and in the series. So this is how we able to create that, how we can create a series. So we can create a series, we can store the data inside any variable, then that variable we can call as a parameter inside the parenthesis of the pd dot series, which means we are using this series function, we can say the functionality with using this pandas library, this pd, which means we have created as a here as a alias of pandas library. So now let's discuss the another program. So now we are going to discuss that series with custom indexing, because earlier by default we are having one index started with 0 1 2, but now I would like to change this indexing part. So let's take another variable, series is equal to 2 pd dot series, then we have already used, then now we can specify the index with abc. Now let's print this series 2 here. So now as you can see, earlier we were having the indexing of 0 1 2, but now we have customized it according to our need, that ABC. Or if you want to make it start with A onwards, so also you can use it if you want to start it with 1 2 3 only, not with 0 by default, so you can change it accordingly 1 2 3 also. So this is how we can customize the index in a series. So now let's discuss the another program. So in another one, I want to show you that series from a NumPy array. How we can create a series by from the NumPy array. We have already imported the libraries, that the pandas and the NumPy. So let's take one variable here, array dot np dot array here. You can choose the short form a. Now let's pass the list here 10, 20, 30 and 40. So now here you can check for the print a also. After that I want to change it in the series, so let's s is equal to pd dot series of a, because I want to convert this into series. So now let's print s. So as you can see, when I try to print this a, so this is the array, this complete one is array here, but then after that I wanted to convert this array into the series. So this is how I able to convert this into series. If you want to change the indexing of it, so you can change it as we have already discussed in the previous one, that a, as you can see here, the the same way we can change the indexing here also, a, then b, c, comma c and comma d. So as you can see, we have changed the indexing also. So this is how we can convert a series, a array into a series. Series from dictionary, how we can convert a dictionary from into the data frame, that one we have already discussed. Or a series, a dictionary into the data frame, this part we have already discussed. So let's discuss this series from dictionary. We have discussed the data frame from dictionary, so now let's discuss the series from dictionary. Library we have already imported, so let's store the values inside the dictionary first. Now let's store the country and their capital name, New Delhi. then UK. Let's store the value here, that is London. Let's store another one, Japan. Capital is Tokyo. So here we are having this dictionary here. So in this dictionary, I want to store the data. Now let's take the another variable series 4 here. So pd dot series, always use the capital S, otherwise it will throw an error because Python is a case sensitive language. So now let's take the printout of this series 4 variable. So as you can see, whenever we are going to convert a series into whenever we are going to convert the dictionary into series or into the data frame, so the key and value, in the key and value pair we are storing the data in dictionary. So this India is a key here and this New Delhi is the value here, which means this New Delhi is the value which we have assigned to this key. So it also means that this key will be treated as index. As you can see here, India, UK and Japan we are having here as an index, and this New Delhi, London and Tokyo we are having it as a value here. So now the default data type of this data is object, but you will say, sir, that this the data type of this should be a string because we have stored inside the single inverted commas or the double inverted commas. So but I will say that in Pandas the string character is treated as a object. Float will be the float only, integer will be the integer only, but string will be treated as the object. It will be displayed as a object. So now let's move to the another part. Now we are going to discuss about the indexing in series. Indexing in series. Let's declare the variable here, that is spd.series, and now let's pass the values here 10, 20, 30, 40 and 50. Now I want to access print that element at index index 2 is, I want to print this. So S, we can use the indexing. The way we were used to do the slicing and the indexing by using the range in the list, also in the top in all other data types also, in the same way we are going to use in the series also. As you can see, this list I have converted into the series by using pd.series. After that I wanted to print whatever will be the inside the double inverted commas. It will be displayed as it is, that the element at index 2 is this, and now here we are doing the indexing. So this 0 is at the this 10 at the 0 indexing, 20 value is stored at the 1 indexing, and the this 30 value is stored at the second indexing. So now let's print this and check. So we are having this value here, that is 30, so which means 0 1 0 1 and 2. So now if you will try to print this complete one, now let's print S here. So as you can see, this was the complete series. So as you can see, at the 0 index we are having the value 10, 1 index 20, and second indexing we are having the value as here is 30. As you if you are going to store a series of name of students in a series, name of their marks and everything, if you are going to store the data in a table, so by default in the Excel, if you are going to store, so by default there is a column on the very left hand side, that is a series like 1 2 3, the number of rows here, or we mainly while writing manually we usually write the very first column, that is a serial number. So we can consider this is a labeled column, or we can say as a indexing one. So by default, the data type is integer 64. Then we have space. We wanted to access that what is which element has stored at the index of 2. So we got the answer, that is 30. Now let's change it by 4 and then run again. So that is 50. So I hope by using the indexing you can access the values in a series. Let's discuss the one more example. S is equal to PD dot series 1 2 3. Let's modify the index here only. Jan, Feb, March. Now let's print this S first. Now let's do the indexing here, that print S, and inside this, according to the indexing I want to access, so let's access that which month is this. This is second month. So this is how you can just store the value in the same at the same time you can do the indexing also, as well as you can modify the indexing also. So now let's discuss, if we are already discussing about the indexing, so we must discuss about the slicing part also, that slicing series. Let's declare this variable again, pd dot series 10 20 30 40 50, and then print this s. Now I want to access with the range of 1 to 4. So 1 to 4 we are having 20 30 and 40, because by default series starts with the 0 indexing. So this is the 0 indexing, and fourth one will be excluded, because whenever we are going to use this as a range here, so the final value always exclude. So 1 to 4, which means the data will be displayed which is stored at first indexing, second indexing, and third indexing. So this is how we can slice a series. Now we are going to discuss more how we can modify series value. Libraries we have already imported. Let's take the variable s pd dot series. In series we are having data stored at 10 20 30 40 50. Then let's print the s first. So this is, we are having the series here, but I want to modify it. I want to modify, that is, at the place of 3. At the place of 3, I want you to enter 100. So now let's print s this time. So as you can see, earlier when we try to print this series, so we were having the data 10 20 30 40 50, and after that we have updated the series here, that with the value of 100. So at the place of 3, as you can see, at the third indexing, the value is stored is 100. So this is how, with using the indexing, modify series value using indexing. So by using indexing, you can change or you can modify the existing value in a series. Okay. So now let's discuss about the series attributes. In series attributes, let's discuss. First, let's declare the variable pd dot series again. Then 20, 30, 40, and 50. Now I want to print the values. So the value of this will be s dot values. Then I want to check the size of this series. So size s dot size. Now I want to check the shape as well as the indexing also, so you can check here, as well as I want to check that this series is empty or not. Let's check for the empty. So s dot empty. After this, by default, a data will be displayed only, so no need to discuss that part. So now let's run this. So as you can see, the value in this series are 10, 20, 30, 40 and 50. Size is 5, which means how many elements are stored here? That is 10, 20, 30, 40 and 50. What is the shape of this? Shape of this, that is 5 rows we are having, 5 columns we are having, but only single row. So as well as not 5 columns we can say here. Okay. So because we are not having the further like this is the one dimensional array, so it will be returned as a 5 whatever the elements we are having. And as well as index, in index we are choosing as a start, stop and this step. So start, which is initial value, stop, which is final value. Final value always exclude, so it will start with 0. So 10 is at 0, 1, 2, 3 and 4. Fourth will be 50. So it will start with 0 and stop at 5 and step is 1, which means at the gap of 1, 0, then 1, again 1 if you are going to add, then 2, then 3, then 4. Is empty, we are checking it, then it will return the output in the terms of boolean value, boolean data type, that it will be true and false. So this series is not empty, so it will return false. If the series will be empty, so it will return a true. So now we are going to discuss about the head and tail function here. So I have taken this series here. So what I want to print, s head let's take few more values here to understand this in a proper way. 80, 90 and 100. Then let's print the s dot tail here. So now head and tail by default they used to display the first, head will display the first 5 records and tail will display the last 5 records. So first 5 we were having from 0 to 4, that is 50, and last 5 were 5, 6, 7, 8, 9, that will be 60 to 100. If you want to get the result according to your need, like if you want to decrease it, if you want to increase it, so you can do it accordingly. So as you can see here, head is starting with for 2 only, that is 0 and 1, and this one for 6 like 4 to 9. So I hope this is clear to all of you. By default it returns first 5 for head and last 5 for tail. So by default they used to return the first 5 and the last 5 only, but you can, if you want to change, if you want to modify like first 2, first 6 only, so you can specify as a parameter here. So now I want to discuss the counting the non null values. This is the one of the major important part by using the count, that counting the non null values. Because in a data set, the most challenging part is the missing value, we can say, uh, duplicate values. So removing the duplicate records, values, as well as the how we can tackle the missing values, the duplicate values and missing values. These are the two major challenge whenever we are going to play with the data, whenever we are going to do the data analysis. So for that, first we will count the non null values, that how many non null values are present in our data set. So now let's take the variable here as pd dot series 10 20 30 40. Now let's take this npnan here, this npnan, which means not a number, which means numpy, this is a null value here basically. So I will count how many non null values here. So now let's count. We are having four values here. So 1, 2, 3, and 4. Because the another one is a other one is a null value. But I wanted to count only the non-null values. So this is how I can count. Because if you like, if you have a data set, if and you want to check regarding the particular column in a data frame or in a series, so if you are having a data set, so mostly we will be using the data frame only in the data analysis, because we will be dealing with the multiple rows and columns. So in that one, if you want to check for the particular column, that how many non null values are there, how many null values are there, so for that you can easily count it. So now we are going to discuss the another function, another one, that is mathematical operations. We are going to discuss that the addition of two series. Let's declare the variable s1 here, then pd dot series. Let's store 10 20 30. Now let's store 40 50 and 60. Pd dot series 40 50 and 60. I want to add both of these series, so just simply as we were earlier we were using it, print s1 plus s2, but I want to specify the index also here. So now let's specify the index A, then B, then C. For this one, I want to pass it D, E, and F. 40, 50, 60. Okay. Now let's pass the same indexing. Okay. So this is how we can add two series, 10, 20, 30, 40, 50, and 60. So this will be 50, 70, and this will be the 90. But as you can see earlier, I have changed the indexing. Now let's change the indexing of only this. So this means there will be null value. Null value because the index of this element is different and the index is of this element is different. Whenever you are going, it means simply means whenever we are going to add two series, it is must that both of the series, their elements, their data items are stored at the proper indexing. Because as you can see, this 20 value is stored at the indexing B and this 30 value is stored at the indexing C. Same, this 50 is also stored at the indexing B and the 60 is stored at the indexing C. So this is how they successfully added here, that this value is 70 and the value is 90. But this one will give us the not a number, that will be giving a, we can say, missing value, because now in this one we are not able to add this number to this series, because in this series there is no indexing A, as well as in the for this series there is no indexing D. So if you want to add it, you have to change it with indexing A, and then only it will give the proper result. So I hope this also clear to you, because so that you are not going to face any error. So now our next program is that addition with fill value. Let's discuss about this. Let's create the series 1 here, series 1 pd dot series, store the data 1 2 3, and same you can copy paste here also, that indexing. Now let's choose that will be a comma b and comma c, separate with comma here also. S2 pd dot series, then let's store the value 10 20 pd dot series here. Then index, I want to set the index as a comma b. Now I want to fill the value here, print s1, because as you can see I want to fill one value here at the indexing level. At the indexing is 2, because 0 1 and 2. Here in the series 1 we are having the 3 value at the indexing of 2, but here the c indexing, as you can see here, that is missing. So I want to add here. So how I can add? I want to add in s1. First let's add these two series. So add s2, we are having, in this one we are having fill value with 30. Now let's print. Okay, there's a spelling mistake. Yes, as you can see here, this is how we have added. But now you will say, sir, the result is in the float. So whenever we are going to add two series, the result with the fill value, the result will be given in the float here. So now as you can see, ABC is here, this ABC. If you, without without filling this value, if you will print S1 and S2, so the result will be here. As you can see, there will be not a number, which means because this C will not be able to add here, but this A to A will be added, this B to B will be added. So while doing the addition with using the fill values, there will be in the float data type, it will be the output. So by default, as you can see here, with the fill value, we have filled the value here at the index of C, and now we are having the proper output here. Now we are going to discuss that how we can create data frame from list of dictionaries. So list of dictionaries, which means we will be having a lot of dictionaries stored inside a list, and how we can convert from that list to a data frame. So libraries we have already imported, that is pandas. So now let's take the data as a variable here, and inside the list we are going to store the, in dictionary we are storing the values as a data as a key value pair. B value is 20. Then let's take another dictionary, then again A 20, take B 30. Now let's convert this into data frame, that pd.dataFrame data, and now this, let's print this data frame. So as you can see that we have converted the list of dictionaries. This is the list, dictionary 1, dictionary 2, and this was we were having this one complete list. We have stored inside the variable data. Now this data, by using this variable, we have converted this list of dictionaries into data frame. So from now onwards, we are going to discuss some operations on rows and columns. So let's discuss the first operation, that adding column in data frame. So right now we are having how many columns? We are having only two, A and B. So now I want to add one more column here. So I will add data frame. I want to add here is C column, and in this C column I want to store the data 40 and 50. Now let this print this data frame. As you can see, now we have successfully added one more column in the data frame. So now let's discuss how to adding row in a data frame. So for adding a row in a data frame, I will introduce you with one function, that is LOC. Or if you want to insert like this also, then also you can insert it, that pd.dataframe. You have used one list here, and in the same way you can pass the another one. But I will tell you that how you can use the LOC function here. At the index level 2, I want to store the data which I want to store, that will be 60, 70 and 80. One more row I want to insert here. So as you can see, this indexing I have passed here, value is 2, 0 indexing, first indexing, and at the second one I want to store these values here. So as you can see, we have successfully added one another row here, 60, 70 and 80. So now I will explain you in detail why we are using this LOC just after these two programs. Let's discuss first how we can delete a column, and as well as how we can delete a row in a data frame, because we have discussed how we can add. So we will be discussing how to delete as well as how we can rename it. Then we will be discussing about this LOC function in detail, because this LOC function is used inside the pandas for accessing and modifying the rows and columns. So as you can see, we have modified this data frame with adding one new row. So we have used here this LOC function here. So first, so now let's discuss first that delete a column in data frame. So to delete a column in a data frame, the same data set we are having. So we will drop which column you want to drop. So let's uh, drop this B1. So I wanted to drop this B1. For that, I want to specify here that that I want to delete the column, or I want to delete the the row here by using the axis. So if you are going to write here axis is equal to 0, then it means you are going to delete the row. If you are mentioning the axis is equal to 1, then it means you want to delete a column. So now let's check here, data frame dot drop. Let's use another variable here one more time. Yes. So now as you can see, this B column has been deleted from this. If you want to delete one more column, so in the same way, just specify the column name and X is 1. X is 1 we are using here just to mention, just to inform that we want to delete the column. If you are going to write here 0, then it means you are working on a row wise. So we can delete a row in a data frame by passing the axis is equal to 0 also, as well as without passing the axis is equal to 0. Also we can delete a row in a data frame, because by default this drop function works on record only, but if we need to delete a column, then only we need to specify the axis 1. So it will work in both cases, if you will specify the axis is equal to 0 or if you will not specify the axis. So in both cases it will be correct. So now let's take the one data set here, A10. Let's take another key here, that is 20. Let's take the same data set which we were using earlier here only. Now let's convert this into data frame first, then df is equal to df, then use this drop, and I want to delete it from the index 1. It's up to you, if you want to specify the indexing then also it will work, and if you do not want to specify then also it will work. So as you can see, index 1 is deleted here. If you want to check the previous data frame, so you can check it from here. So earlier we were having this data frame that 10, 20 and 20 and 30, A and B was the column, 0 and 1 was the indexing. So after deleting the first record, this 120 and 30, we are having now this data set. So this is how we can do it, or at the same time you can pass this as a axis here, that is equal to 0. This is for the row here. So in the both cases it will work. So by default it used to delete the row only, this drop function. So now let's discuss how we can rename a column. Renaming a column in data frame. So let's take a data set here, name. Now let's take a list here, Mohan, Sohan, Arman. Let's take another key value set, that marks of these students, 40, 100 and 50. And now let's convert this data variable into data frame, and let's print first. So now I wanted to change their df is equal to df dot rename. So this column name, I want to change it as a student. So now let's print it again. So as you can see, the previous one we were having name, marks, and now I have changed into the student and then marks. So this is how we can rename a column in a data frame. So now I would like to explain you about the LOC. So which we have already discussed regarding the LOC. So LOC we mainly used, it is used to modify and access rows and columns in a data frame using labels. This is the use of LOC in data frame, that we can do some sort of modification if you want to access the rows and columns. As we have used this LOC here for adding a row in a data frame. So we were modifying this data frame. I wanted to add one more row here. So for modifying the database, I have used this LOC function. So now let's discuss few operation based upon this. Let's discuss the first one, that select rows using LOC. Let's take a variable here that is data. Inside the data, let's use this same one. So now in this one, I want to access. Let's first convert this into data frame into pd dot data frame, this data, and now I wanted to print df.loc only which is at indexing 1. For passing the indexing, always use the square bracket. Yes. So let's print the original one also, so that it will be easy to do the comparison. So as you can see, here we are having this complete data frame, which we have converted this dictionary into the data frame. So, but I wanted to access only, select, or you can say access rows using the LOC. So I have used here the indexing 1, and I have displayed only the particular one record here, that is of Sohan. Now let's discuss how we can select multiple rows using select multiple rows using LOC. How we can select it, that data frame dot LOC. Let's use this function range here, that I wanted to display 1 and 2, so I will use 1 2 3 because the final one will be excluded here, right? So let's display this. So as you can see here, Sohan and Arman we are having, not Mohan. So for Mohan we have to pass from 0 to 3, then only it will be included, Mohan, Sohan and Arman. So this is how we can use the range here, that selecting multiple rows using LOC and range. So now let's discuss the conditional selection using LOC also. Conditional selection using LOC. So now in this one, let's take data name, pass a list here of name like Mohan, Sohan. Let's pass few more names here. Arman, Ritik. Let's pass another that is of marks. 40, 33, 100, 78. Now let's convert this into data frame, and now let's run this. So now see what we are doing here is, inside this one will also come. Yes. So what we are doing here, first we have stored uh, this dictionary into the variable data. Then we have converted this data, this variable into data frame. So after that, now let's print this data frame first, then I will explain you the conditioning. So this is the complete data frame which we have stored here. But now I want to apply the condition here that one who scored the marks above uh, 35. So I want to display only that record. So those who have scored above the 35, the names are Mohan, Arman and Ritik. Mohan, Arman and Ritik, because this Sohan has scored only 33 marks. So this is how we can apply the conditional selections using the LOC, which means we can extract only the specific data from the complete entire data frame or the data set according to your use only. For let's consider that you have imported a big CSV file, big comma separated value files, or we can say big data set into your Python program. So you have a lot of data and you want only specific data from that completed data set. So this is how you can retrieve the data from a big data set according to your specific condition and according to your specific criteria. So now let's discuss how we can modify using this LOC. So modify using LOC. Let's take the same data frame here. Let's copy this part. So now let's print this data frame. So we are having this data frame, but I wanted to modify the marks of Arman, that by mistake teacher has entered this marks as 100 here, but I wanted to update this marks as a 90. So the place is second, comma, then marks and the value which you want to update it. Now let's print this data frame again. So as you can see, the marks has been updated from 100 to 90. So this is how you can use the LOC. So we have discussed a few operations using the LOC. That LOC is used to modify and access rows and columns in a data frame using the labels, or we can say the index, because as you can see we are using the indexing here. Every time we are using the indexing here, or the range. Then we have discussed how we can select multiple rows using the LOC and range. Then we have discussed the conditional selection using the LOC. If you want to retrieve only specific data out of complete data set or the data frame. Then we have discussed how we can modify the data using LOC. And then now we are going to discuss our one of the main topic which we have left, the last one, that is the importing and exporting the CSV files. So let's discuss file programs. In the file programs we will discuss importing and exporting CSV files. While importing, which means we are importing the CSV file to the data frame, and while exporting, which means we are uh, exporting our data frame to the CSV files. So let's discuss by the first program that we will be discussing, that importing a CSV file in data frame. So for that, let's take a variable here, data frame, then pd dot read, then csv, then bracket starts. Now in this side, the inside the parenthesis, we will copy the path of the file. So while using the Google Colab, you have to click on the files, and inside the files, as you can see, I have already uploaded the CSV file in my Google Drive. So first you have to click, like you have to upload your files in the Google Drive, then you have to connect your Google Colab with the Google Drive. For that you have to click on this mount drive. So now the mounting has been done. So if you want to permit this notebook to access your Google Drive files, then you have to click on connect to Google Drive, then choose your account with which you want to connect it. As you can see, the mounting has been done. Wait for few seconds. So let's try to add this file, California house. I want to copy this path, and now let's paste this path here, and then now let's print this data frame. Inside the parenthesis we should pass here. So as you can see, we have successfully imported this CSV file in our Google Colab. So this is the complete data set, and in this data set, as you can see, that we are having 3000 rows, as well as we are having 9 columns here. So now let's, if you want to display only the first 5, that df dot head, so it will display only the first 5 records. So as you can see, first 5 records we are having of 9 columns: 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we are having 9 columns here, and first 5 records I wanted to display, so I have used this data frame dot head. So in the same way, like if you want to export any data to a particular CSV file, so for that, uh, exporting data frame to CSV file. For this, let's discuss, like, first let's create the, we have already imported the library, so no need to import it again and again. So now let's take this data as a variable here, and inside this variable, let's consider this name, then store the value here, Mohan Vishal Raman, and their age is like 20, 60, 34. So now let's convert this data frame, this dictionary into data frame first. Now let's store this data into this file, data.csv. So now let's try to access this file, because right now we have exported our data frame to this CSV file. Now I want to check that the data is actually stored in this file or not. So for checking the data, same, again we are going to use this one, that data frame dot is equal to pd dot read csv, and what my file name is data dot csv. Now print data frame. So as you can see, I have exported my data frame first, this data frame to this file data CSV, and now I am able to retrieve my data, able to access my data from this CSV file. So this is how you can import and export the data to a CSV file, and from CSV data frame to CSV file, and as well as from CSV file how we can access the data. So this is basically importing and exporting of data frame to a CSV file. So if you are using the Google Colab, you must connect your Google Drive with it. So you just need to click on this file, then mount your drive with it. Once you have to click on this, then you have to click on connect. It will connect your Google Colab to the Google Drive. Then just upload the CSV file, whatever you want to use here inside the Google Drive, and then you can easily access from here. Just copy the path and then just use that CSV file in your programs. That will be very easy. Like if you are using the another platforms, so for that what you have to do, just download any particular CSV file, then go to the properties and just copy the path of the file, and then paste the path of the file, and then you can access all the content of that file. So that was the part of our today's session. So in the next part there will be one more part of the data analysis with pandas. In that one we are going to discuss whatever we have left with the data analysis part. So I hope everyone has enjoyed this video.